Let's now have a look at how a convolution layer works. Let's have a look at how a convolution layer actually works. Just imagine this is a representation of an image in a multidimensional array, or sometimes it's called tensors, right? And then let's consider we have a 2 by 2 filters. 2 by 2 filters, and the operation is very simple. We just uh, slide these filters over this image, input image, each 2 by 2 block of the input image, as we have a filter of 2 by 2 size. So if we had a filter of 5 by 5 size, we had a slide over each 5 by 5 block of our input image until we finish all 5 by 5 blocks. So here we have just only 2 by 2 filters, so we will slide this 2 by 2 filters over starting from this 2 by 2 block until this 2 by 2 block. So basically we're going to slide over the input image. We're going to slide the filter 2 by 2 filter over the input image until it finishes, until it reaches the last block, last 2 by 2 block of input image. So as we slide over, um, as we can see, when we slide over this yellow 2 by 2 block, we'll perform a dot product, and we'll sum the products, and we'll store the value in this place. And this is how a convolution works. So if we perform a dot product with this 2 by 2 block, we'll get an output of 2. So this array or multidimensional array gives us a whole new representation of an input image. So this kind of operation, this kind of convolution, the sliding over of an input image, is called convolution. So this kind of convolution happens at every convolution layer, and this is how convolution works. So when image passes through hundreds of convolution layer, so we would be able to detect many complex features, complex patterns. A pattern could be a circle or edges, many different things. So another thing we have say we have used for max pooling. Max pooling is basically used to reduce the dimensionality of input image. So the computational time decreases, the cost decreases. So it helps us to reduce the computation time of a model. So the basic idea here is we use a max pooling, 2 by 2 max pooling with a stride 2. So here we it's just like a filtering. We have just take a first 2 by 2 block, and we uh, first 2 by 2 block, and we select the maximum number containing in that block. So maximum number in this red block is 2, so we place 2, we store 2 here, and we stride over two two columns in the images to the next 2 by 2 2 by 2 block. So this is how it works. So the next 2 by 2 blocks, 4 is the maximum number, and we store 4 here. This is how max pooling helps us to reduce the dimensionality, so we can reduce the computational time of a model. So let's go back to the main images. So let's have a last overview. So we have two layers, a convolution layers, and a artificial neural networks layers, also known as fully connected layers. And so here is the input. We're giving an image as input, and this image is convolves across this convolution layers. And as I have said already, it may contain a one or more, or a thousand and hundreds of convolution neural networks. Then we flatten the inputs so we can fade into the fully connected layers. And as I have said earlier, fully connected layer may contain hundreds or thousands of convolution neural network depending on the dataset we are using. So, and the output layer will contain number of nodes, same as the number of classes of images when classify. So this is the simple overview of convolution neural networks, and thank you for watching. Thank you.